All right, welcome everyone. What this is going to be is this is going to be me going and recording myself trying to solve through your conversion just practice homework. Now, something that I will say before I get started, everyone's conversion practice homework, the numbers are randomly generated. So these numbers are generated for me, but the way in which you solve any of these problems is all the exact same. Also, I am not going to be able to show you my calculator, meaning that if you get a different value than me with the same math, you need to check your calculator just to see exactly what you are doing. So let's get started. The very first one is convert 2.6 miles into inches, and I want to round to one decimal place if it is necessary. Let's choose a nice narrowing screen. So again, your conversions always have 5 steps. And for the beginning, I'll just go and I'll write, oh, green's not a good color. Let's go to blue. Or first write our 5 steps. Number one is you always start with your known. And the known with any of these problems is always just going to be the numbers of whatever your starting point, your known is right here as 2.6 miles. The second step is to write your end goal. So you want to make sure that you have an end goal in mind of here, my starting point is miles, my end goal is to get that unit into inches. The third step is to determine a conversion factor of you want to say, what are my current units? What units do I need then? What do I know about those units? And finally, you are going to determine the correct orientation of that conversion factor. So does that conversion factor go with miles at the bottom, miles at the top? The fun part about this then is that you repeat numbers 3 and 4 until infinity. Specifically, the infinity comes whenever your units on your actual conversion match your end goal. So you repeat 3 and 4. Just keep on going, keep on going, keep on going until you get your end goal, until finally you solve the problem with your calculator. Those are your 5 steps for every single type of conversion problem. So let's go through then and solve this conversion together. I'm going to start off with my known, and my known is 2.6 miles. On the other side of my page, I'm going to write what I want, my end goal. It is inches. Now, students go and they ask me, Mr. Tate, how do you know with your conversion factor what your next step is going to be? And I tell you that I don't. I don't plan these out with it. What I do is I follow the units. Right now, I have miles. If I want miles to cancel, then they always have to be written on the opposite side of my specific dividend, this line. So I put miles down at the bottom. And then I go and I try and find, well, what the heck do I have that are actual miles? Let me show you. I went and I pulled up both our SI unit chart and our conversion sheet. This conversion sheet, again, is what I gave you for very, very common conversions. All I do, I look for miles. And I say, okay, I can either turn miles into yards, I can turn miles into feet, or I can turn miles into kilometers. I think that the easiest conversion for me, because I want to get into inches, and I see that inches and feet are right here, is that let's go and let's turn miles into feet. So I have 1 mile is 5,280 feet. Let's do it together. I write once again my conversion factor. 1 mile, oh, always red. 1 mile equals 5,280 feet. So I start there. this is my conversion factor, and I need to determine the correct orientation, where my numbers go. I have miles down at the bottom because I need to cancel my units. So I need to write feet up at the top then. Notice this number, the 5,280, goes with feet, and the 1 goes with miles. I cancel out my current unit, miles, and now my unit is feet. I check then, is feet my end goal, inches? In this case, nope, meaning I need to keep on going. I am going to multiply by another conversion factor. I'm in the unit feet. I want to cancel out feet. I want to change feet then into inches because I know the conversion factor, 1 foot is equal to 12 inches. In which case, the 1 goes with the feet and the 12 goes with the inches. Now, I cancel out my units and I'm in the unit inches. My end goal is the unit inches, meaning that I can go and I can solve it. For your 5th step, in order to solve, you multiply everything on the top. So I'm going to take 2.6 times 5,280 times 12. And I'm going to divide that by everything on the bottom. But thankfully here, my bottom is just 1 times 1, so I don't need to worry about my denominator. But my numerator, absolutely, let's plug it in. 2.6 times 5,280 times 12 equals. And I get the value 164,736. 164,736. Notice there are no decimals, so I don't need to round, inches. That's my final answer. I have 164,736 inches in 2.6 miles. That's number 1. Let's head on to number 2. Number 2 is 5.4 days into seconds and round to 1 decimal point if necessary. Same exact setup. Start with your known, 5.4 days. On the other side, put your end goal. Here it is seconds for me. Let's multiply by a conversion factor, knowing that I want to cancel out days. And I just ask myself, what do I know about days? Now, a way for you to plan this and to kind of think about what you want to turn it into is you notice exactly what direction you're going. And what I mean by that is your end goal seconds is much smaller length of time than days, meaning I want to turn days into a smaller length of time. I know the conversion factor, 1 day is equal to 24 hours. So I plug that in. 1 day, 24 hours. Cancel out days. And my current unit right now is hours. Again, I'm not going and I'm not saying, well, I don't know what my next step is. All I know, my unit's hours. I want to cancel out hours. What do I know about an hour then? And with it getting smaller, I know that 1 hour is equal to 60 seconds. Whoa. Not seconds. Minutes. I was like, wait, hold on. So now I'm just going to change hours into minutes. 1 hour, 60 minutes. Cancel out hours. And now my current unit are minutes. Since they don't match, I have one more step. I cancel out the unit minutes. I know my conversion factor, 1 minute equals 60 seconds. So I write it, 1 minute is 60 seconds. Cancel out minutes. And now my units match, meaning I can solve. Again, what I am going to do, I'm going to take everything at the top. I'm going to take 5.4 times 24 times 60 times 60 in my calculator. So I do 5.4 times 24 times 60 times 60, and I get the answer of equals 466,560. 4,066, 560 seconds. Awesome. So that then is your final answer for problem number 2. Let's keep on going. Problem number 3 is to convert 78,122 centimeters into kilometers. Okay, notice these are both metric prefixes. They match with the SI unit meters. That is going to be so very important in a couple of seconds. So what I want to do, same rules. Start with your known. 78,122 centimeters. On the other side then, I write my, oh, no. Back. Erase. Come on. Eraser. There we go. Awesome. No, oh, man. All right. Once again, start with your known, 78,122 centimeters. On the other side, write your end goal. Here it is kilometers for me. And let's get started. First thing, again, all I want to do is I want to convert out centimeters. This is where this problem becomes so and very important. If you are in metric, turn it into the SI unit. Your SI units are those 8 units that I taught you. They are the building blocks of science. Here, your SI unit is meters. So turn your centimeters into meters first. And you might say, Mr. Tate, well, I don't know this conversion factor. And I agree with you. It's not very common knowledge unless you are a science teacher. But I am one of those people that firmly believe you are going to have just so much of knowledge available to you. In this case, I am going to go and I'm going to give it to you. If you notice, what we have here is we have an SI unit chart. The SI unit chart means this. You look at the specific, can I draw on this? Let's see. Draw. All right, we're going to count it. You look at the specific value then for this prefix of what it is. I want to look at the prefix centi. And here, why isn't drawing working? My prefix centi is going, and it is making sure that I can then check how many SI units I have. Here, it always follows this pattern. 1, whatever prefix I have, equals this many SI units. So my metric conversion is going to be 1 centimeter equals 0.01 meters. Or in this case, 1 kilometer equals 1,000 meters. That is how you read that chart specifically to try and figure out your value. So if we go back to our problem, and I go back so I can draw, I have 1 centimeter. Why is it always red? 1 centimeter equals, come on. Color. Let's go back to blue. 1 centimeter equals 0.01 meters, 0.01 SI units. So I put the 1 with the centimeters, 0.01 with meters, cancel out centimeters. Notice, my units don't match though. I want kilometers, meaning I'm not done yet. Same exact pattern. Meters is at the top to cancel. I put meters at the bottom. I want to change it into kilometers. I saw from my SI unit chart that 1 kilometer, just kilo, is 1,000 SI units, 1,000 meters. The 1 goes with kilometers, and then 1,000 goes with meters. I cancel out my units, and now they match, meaning I get to plug it into my calculator. However, this also is the first time that I have a value in the denominator, meaning I am going to take 78,122 times 0.01, and I am going to divide this number by 1,000. That is what I'm going to plug into my calculator. So let's do it together. 78,122 times 0.01. I get 781.22. I divide that number by 1,000, and my answer is going to be, well, first off, my calculator answer is 0.78122 kilometers. I want to round to 4 decimal places, so I look at the first 4 numbers, 1, 2, 3, 4. I notice the 2 doesn't round up, so I leave it as 0.7812 kilometers. All right, problem number 3, and your first metric problem. Let's use that info for problem number 4. Convert 4.13 meters per second into centimeters per minute. This is a double step. I'm going to start the same way, but note that this word per is very specific in science. It means to divide. I am going to have 4.13 meters up at the top, and I am going to divide that number by 1 second. In the end, I want to end up with the units of centimeters per minute. So now what we are going to be doing, we're dealing with more than one unit at a time. Let's make sure that we take our time then and really cancel everything out. The first thing that you need to know is that it doesn't matter the order in which you solve it. The order makes absolutely zero difference. I'm going to go and I'm going to change the meters first into centimeters. And I am going to use the exact same conversion factor that we learned last time. Of 1 centimeter is 0.01 meters. Centi has the prefix 1, and we have 0.01 with my meters. Cancel out your units. And now my current units, and be careful here, are centimeters per second. But I want centimeters per minute, meaning I am not quite done yet. Now, I want to cancel out the unit seconds, and notice that seconds is in the denominator, meaning to cancel out seconds, I put it in the numerator. I want to cancel them into minutes. I know 1 minute is 60 seconds. So I write it as such, and I plug in my conversion in the correct orientation. I cancel out seconds, and now I have centimeters per minute, which is the exact same as I want. So to solve this, I'm going to go and I'm going to take everything at the top, 4.13 times 1, which is still the same, times 60, and divide that by 0.01. So if we plug it in together, 4.13 times 60, I get in my calculator 247.8. I divide that by 0.01, and I get, what is that? That's 24,780 centimeters per minute, which is our answer. All right, one left, and it is our light years problem. Now, we use light years, specifically, I use light years in physics because I want you to use scientific notation for it. So what we do, same exact thing. I start out with 70,000 centimeters. I want to convert it into light years, and L, capital Y, is the notation for light years. All right, what do I want to do? Well, this is one of the times where I feel more than likely we want to go and we want to check out our conversion sheet. So if I choose our conversion sheet and I look what we have for light years, The only thing for light years is meters. So I want to try first to get it into meters, so then I can convert into light year. So let's do that first. I want to convert first into meters, then into light years. And since this is the only time I'm going to come back to this conversion sheet, I need to remember 9.461 times 10 to the 15th meters. So let's once again draw. I know it's going to be red. Oh, caught it this time. Change to pen. And I'm going to write first my centimeters. Let's go back. My centimeters into meters. Centimeters goes at the bottom. I know my metric prefix, 1 centimeter, 0.01 meters, the same we've used for the past 2. Meters, 1, 0.01. And I cancel out my unit centimeters. Now, this is why I changed my unit into meters, is because I know my metric prefix, or not my metric prefix, my meters can change into light years. And our conversion factor was 1 light year equals 9.461 times 10 to the 15th meters. So we determine the orientation, and we say the 1 goes with light years. My scientific notation goes with the meters, 9.461 times 10 to the 15th, and we cancel out our units, meters. Now we know our light years match, so let's solve it. We do 70,000 times 0.01 and divide it by this exponent, or this scientific notation, 9.461 times 10 to the 15th meters. Now, again, to plug this scientific notation into your calculator, use your EE, your exponential equation function here for the times 10. So I am going to do 70,000 times 0.01 equals 700 divided by 9.461 e to the 15th equals. And I get a calculator answer of 7.398 numbers times 10 to the negative 14th. Here, I want 1 decimal place, meaning I am going to look at the first decimal place past my scientific notation. It is a 3, but my 9 rounds that up, so I am going to write it as 7.4 times 10 to the negative 14th light years. That is your final problem and the very end to your conversion practice. As always, thank you, and let me know if you have any questions about these problems. See you, everyone.